Okay, so space travel. Yeah. That's always seemed like something only billionaires can afford,
Yeah.
Like something most of us can only dream about.
For sure.
But there's this article from Newsbomb. It's a Greek news site.
Interesting.
And it says that might all be about to change.
Really?
Yeah. We could be talking like space travel on a budget.
Huh. That's a pretty bold claim.
I know, right?
Yeah.
It definitely caught my eye, too.
Yeah, for sure.
So the article was published on December 18th, 2024.
Okay.
And it talks about how a Japanese company wants to build a space elevator.
A space elevator?
Yeah, to Mars.
Whoa, hold on.
I know. It sounds like sci-fi, right?
It does, yeah.
A space elevator.
Yeah.
But we're going to dig into the science behind it.
Okay.
And it's actually pretty fascinating how much of it is, like, grounded in reality.
So it's not all just...
Yeah, exactly.
Yeah.
Exactly.
Yeah.
So the article, it really gets right to the point. Like, the biggest problem with space travel is the cost.
Totally, yeah.
They talk about NASA's Artemis missions.
Oh, right.
Which cost a mind-blowing $4.1 billion.
$4.1 billion.
Yeah, per launch.
Per launch, wow.
That's like launching a small country's entire GDP into space every time.
Seriously, yeah.
It's insane. For that kind of money, we could...
You could do so much.
I know. You could build a research facility.
Easily.
Yeah.
Yeah.
Right here on Earth.
Absolutely.
So what is it that makes space travel so expensive?
So a lot of it comes down to fuel.
Oh, right.
Getting those massive rockets off the ground.
Yeah.
Takes an incredible amount of energy.
Yeah, makes sense.
Plus, you have to build these, like, incredibly complex spacecraft that can withstand the crazy conditions in space.
There's a hostile environment up there.
Totally. And even the tiniest failure, it can be disastrous.
Yeah.
Both in terms of lives and money.
It's a high-stakes game, for sure.
It really is.
So how does the space elevator, how does it help with that?
Okay, so the basic idea is a tether.
A tether?
Yeah, stretching all the way from Earth to Mars.
What?
Like a cosmic highway.
Okay.
And then these electromagnetic climbers, they transport cargo and eventually people along the tether.
So you're saying no more rockets?
Exactly. No more expensive rocket launches.
Wow. So instead of blasting off, you'd be like taking the elevator up to Mars.
Yeah, pretty much.
That's wild.
It is. And the cost savings, they're incredible.
Yeah.
The article says it could cost as little as $24 per kilogram.
Hold on. $24 a kilo?
Yeah. To send stuff to Mars?
So building materials, equipment, food, water.
All of it.
All that could be shipped to Mars for practically nothing.
Pretty much. It's game-changing.
That is game-changing.
Yeah.
That is crazy. And hold on, wouldn't that be good for the environment too?
Oh, absolutely. No fuel burned during ascent, much greener.
Wow.
Plus less vibration, which is great for sensitive equipment.
Oh, right, like telescopes and stuff?
Exactly. They'd arrive in perfect condition.
Okay, but I gotta ask.
Yeah.
What could this tether possibly be made of?
Right. To stretch across millions of kilometers of space.
I mean, come on.
It's a big question. Right now, they're looking at carbon nanotubes.
Carbon nanotubes?
Yeah, you know those.
Yeah, they're like...
crazy strong.
Stronger than steel?
Yeah, pound for pound.
But super lightweight.
Exactly. They could revolutionize things here on Earth, too.
I've heard about them being used in, like, high-tech bicycles and stuff.
Yeah.
But to build something that goes all the way to Mars?
Right.
That's next level.
It is, and there's a catch.
Uh-oh.
Right now, we can only make them in short lengths.
Like how short?
Meters, maybe kilometers at most.
And for a space elevator, you'd need?
Tens of thousands of kilometers.
Wow. Okay, that's...
yeah.
That's a pretty big difference.
That's the biggest challenge right now.
So is there any way to, bridge that gap? Can we actually make carbon nanotubes that long?
That's what scientists are working on right now.
Okay.
Some are researching how to make longer nanotubes,
right,
and others are looking at weaving shorter ones together.
So like making a rope?
Kinda, yeah.
Except the threads are, like, microscopic.
Exactly.
And the rope has to reach another planet.
It's a massive task.
It seems impossible.
It might be, but think about it.
Yeah.
The Panama Canal, that was considered impossible too.
Yeah, okay.
And the Transcontinental Railroad.
Right.
Those changed everything.
They did, yeah.
The space elevator, it could be like the next huge infrastructure project.
Wow, the next,
Yeah, redefining what humans can do.
It's kind of hard to wrap your head around.
It is.
Okay, so let's say we could solve that materials problem.
Mm-hmm.
Wouldn't that also mean, way faster travel time?
Definitely. Instead of 6 months to Mars,
6 months.
it could take just 40 days.
40 days.
Yeah.
That's like less than some people's commute. What would that do for exploration or even like colonizing Mars?
It would make everything so much more accessible.
Yeah.
Imagine sending resources, building research outposts, even sending colonists.
Wow.
It'd be a whole new era of space exploration.
Like Star Trek stuff.
Kinda, yeah. It could change how we see ourselves in the universe.
Okay, but hold on a sec.
Yeah.
Even if we solve the materials and the travel time, what about all the dangers?
Oh, yeah, of course.
Space debris, solar flares, like even just wear and tear on something that big.
Yeah. All valid concerns.
It's a lot to think about.
It is, but the article mentions anchoring the tether near the equator.
Okay.
That'd help with some weather risks and stability.
Right.
But yeah, security and maintenance would be massive challenges.
Like imagine trying to protect something that large.
Yeah.
It's like guarding the Great Wall of China, but in space.
It'd be a huge undertaking.
Okay, so who's behind this crazy idea?
So the article says it's a Japanese company
Okay.
called Obayashi Corporation.
Obayashi Corporation.
Yeah, and they're seeing this as like a global project.
Really?
Yeah, a public works project for all humanity.
Huh, interesting.
They've even estimated the cost around $100 billion.
100 billion, that's still a lot.
It is.
But it's way less than we spend now.
Oh, yeah, for
And
sure.
this idea of it being for all of humanity, that's kind of cool.
It's a long-term vision.
Yeah.
You know, they want space to be accessible to everyone, not just billionaires and governments. That's
Right.
their goal.
Yeah.
Yeah, it really makes you rethink what's possible.
So we've been talking about this space elevator
Right.
and how it could be a total game changer.
No.
But it's like hard to grasp just how big this thing would be.
It's mind-boggling, right?
It's massive.
We're talking bigger than anything we've ever built.
Like way bigger.
Millions of kilometers long, anchored to Earth, reaching all the way to Mars.
It's hard to even imagine.
And just think about the logistics.
Oh, man.
Getting the materials up there, assembling it in space, it's
Yeah.
almost incomprehensible.
Yeah. It makes you wonder if we can even do it. Like
Yeah.
with the technology we have now.
Right. I mean, how do you even design something that can handle, like, micrometeoroids,
What are those?
tiny space rocks, basically,
Oh.
and solar radiation and the crazy gravity forces?
It's a lot to deal with.
It is, and that's one of the biggest challenges for the engineers.
So how do they even start?
Well, it'd have to be designed with, like, backup system.
Redundant systems, yeah.
Right. And ways to repair itself.
Oh, wow.
And it would have to be super tough, able to handle extreme conditions.
Because any failure could be...
Catastrophic.
Exactly.
Yeah.
And we haven't even talked about the people.
Oh, right. The human factor.
Yeah. Imagine being on that space elevator.
Mm-hmm.
It could take weeks to get to Mars.
Even with the faster travel time.
Yeah. How do you design a space for people to live in that long?
That's a great point, and one that's often overlooked.
Right.
We'd need to think about radiation shielding, maybe artificial gravity.
Artificial gravity like in the movies?
Kinda, yeah, to keep people healthy.
Wow.
But also, you know, psychological stuff, social dynamics.
Like how people interact with each other.
Yeah, it'd be like designing a mini city in space.
That can support life for weeks.
Exactly.
It's like a cruise ship, but in space.
I like that analogy.
But way longer than a cruise.
Yeah, a one-way trip that takes over a month.
It'd be a whole new way to think about space travel.
For sure.
Okay, but this brings up something else.
Yeah.
If it's easier and cheaper to get to Mars,
Uh-huh.
won't everyone want to go?
Probably. Yeah.
And what about Mars itself?
What do you mean?
Like the environment?
Oh, right, the ethical implications.
Exactly. Do we have the right to just take over another planet?
That's a huge question, and there's a lot of debate about it.
Yeah, like, should we try to make Mars more like
Sort of
Earth?
forming, yeah.
Or wouldn't that change it forever?
It would, and some people think we should preserve Mars as it is.
Even if it means fewer humans can live there. Yeah, it's a tough call.
It shows that, like, technology isn't always the only thing to think about
Exactly. We need to consider the ethics too.
before we rush off to colonize another planet.
Absolutely. We need to understand the long-term impact.
On both Mars and ourselves.
Right.
It's a big responsibility.
It really is.
But on the other hand, imagine the science we could do on Mars.
oh, yeah, the possibilities are incredible.
If we could get there more easily.
Think about it. We've been sending robots and probes,
For years.
but imagine having actual scientists there.
In, like, research stations?
Yeah, they could do experiments, explore firsthand.
It'd be like a whole new chapter.
In our understanding of the solar system, maybe even life itself.
It'd be amazing.
And think about the inspiration.
Oh, yeah, like the moon landing.
Exactly. A space elevator could inspire a whole new generation.
To get into science and technology.
Yeah, to push the boundaries of what we know.
It could be the thing that makes us a multiplanetary species.
I like that.
Okay, but we need to be realistic here.
We've talked about the initial cost, but what about all the other expenses?
Oh, yeah, the long-term stuff.
Yeah, like you don't just build a space elevator.
Right.
You got to maintain it, upgrade it, keep it safe.
For a very long time, potentially centuries.
So who pays for all that?
That's a good question.
Would it be like all the governments together?
Probably partly, yeah.
Or maybe private companies?
It would probably be a mix.
Like a global effort.
Exactly.
Wow.
A true international collaboration.
The governments, companies, scientists, all working together.
Yeah, to make this happen.
That's kind of hard to imagine.
It is, but the potential rewards are huge.
If we can figure it all out.
The space elevator could completely change how we see space.
And maybe even ourselves.
It's a testament to human ambition, this drive to push the limits.
Yeah, even if it takes decades.
Why?
Just trying to achieve something like this can lead to incredible innovation.
And inspire us to reach for the stars.
Okay, but let's zoom back in for a minute. We've been talking about the space elevator itself.
Right.
But what about us?
Here on Earth.
Yeah, how would a project like this change our lives?
Even if we never go to Mars ourselves.
That's a great question.
Think about the technology we'd need to develop.
Oh, yeah, for sure.
New materials, robotics, energy production.
AI, all that stuff.
Exactly. And all those advancements could have benefits here on Earth, too.
Like a ripple effect.
Yeah, one innovation leads to another.
New materials that are stronger and lighter.
More efficient energy.
Better robots.
It could revolutionize industries.
It's like planting a seed in space.
And watching it grow into a forest of new technology back home.
I like that.
And don't forget the economic impact.
Oh, right.
Jobs, investment, global trade.
It'd be a massive project.
A global workforce, all working towards a common goal.
That's pretty inspiring.
It is.
But I think there's something even deeper here.
What do you mean?
Like philosophically.
Oh, I see.
How would it change us as humans?
You're right, to have a permanent presence on another planet.
Yeah, would it change how we see Earth?
Maybe make us appreciate it more?
Realize how fragile it is.
It's hard to say for sure.
But imagine waking up every day.
Knowing there are people living on Mars.
Building communities, maybe even families.
It would change our whole understanding of what it means to be human.
It'd be like that moment when our ancestors first left Africa.
Or when we landed on the moon.
A huge leap forward.
Expanding our horizons, challenging our assumptions.
Opening up all these new possibilities.
Yeah, it's pretty exciting to think about.
So we've been talking about all this amazing potential of a space elevator.
Right, like revolutionizing space travel.
Yeah, and maybe even leading to, like, breakthroughs here on Earth.
Exactly.
But we got to be real. Not everyone is on board with this.
Yeah, there are definitely some critics out there.
People who think a space elevator is just, like, impossible.
At least with what we can do right now.
So what are they worried about?
Well, a lot of it comes back to those material challenges we talked about.
The carbon nanotubes, right?
Yeah, some experts say even with all the research, we're still way far off from making a tether that's strong enough.
Strong enough and also, like...
Big enough?
Yeah, long enough.
Millions of kilometers is a lot to cover.
It's mind-blowing.
Some people think we're decades, maybe even centuries away.
Wow, really?
Yeah, it's pushing the limits of material science, that's for sure.
And even if we could make a material that strong, could we even produce enough of it?
That's another big question. The scale of this project is enormous.
We'd need a crazy amount of material.
Some critics say those resources could be used for other things.
Like solving problems here on Earth.
Yeah, like climate change, poverty.
So it's not just about whether we can do it.
It's also about, like, what should we be focusing on?
Right, what are our priorities?
Exactly.
And then there's the whole issue of, like, what could go wrong?
Oh, yeah, the risks.
With something this big and complicated.
Accidents are bound to happen.
Like, what if the tether breaks?
Or a climber malfunctions.
And falls back to Earth?
It doesn't bear thinking about.
It'd be devastating.
For sure, both in terms of lives and money.
That's a scary thought.
It is, and it's something everyone has to consider.
Even the people who really believe in this idea?
Yeah, no one's denying the risks.
And it's not just accidents, right?
No, there's also the potential for sabotage.
Like terrorism?
Potentially, yeah.
Wow.
If someone wanted to cause damage, a space elevator would be a big target.
Like cutting off our connection to Mars.
Exactly, it'd be a huge blow.
So how do you even protect something like that?
That's a big challenge. Security would be a top priority.
It'd be like the most important thing in the world to protect.
Pretty much, yeah.
It's a lot to think about.
It is, but these are conversations we need to have.
Yeah, about the risks and the rewards.
Gotta weigh everything carefully.
But even if a space elevator never gets built, just thinking about it, trying to figure it out.
It could lead to amazing discoveries.
Like in other fields.
Exactly. Look at the Apollo program.
The moon landing.
Yeah, it wasn't just about getting to the moon.
It led to so many new technologies.
That we use every day.
GPS, satellites, even medical imaging.
It's incredible to think about.
So even a failed project can still change the world.
Exactly. It pushes us to think differently, to innovate.
To try new things.
And that's how progress happens.
Okay, so as we wrap up this deep dive, what's the main takeaway?
I think the key is this conversation is just starting.
About space elevators.
Yeah, and about our future in space.
That's a pretty bold idea.
Audacious, even.
But it makes us think big, right?
It does. It challenges us to push our limits.
And to imagine what it would be like.
To be a multiplanetary species.
To live on other worlds.
It's exciting and a little bit scary.
Yeah, definitely both.
But whether or not we ever build a space elevator, just the fact that we're dreaming about it,
and trying to figure it out.
it shows what humans are capable of.
We're not just sitting here watching the universe go by.
We're actively trying to shape it.
To create our own future among the stars.
That's a pretty powerful idea.
It is. And on that note, I think we'll wrap things up.
Sounds good.
Thanks for joining us on this deep dive into the world of space elevators.
It's been a fascinating conversation.
Until next time, keep looking up.
And keep exploring.